everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to continue taking notes on Section 3 of Chapter 1, solving equations with a variable on both sides. But we're going to take a look now at having more than just a single variable and number on each side. Our first example is 3x minus 10 plus 4x equals negative 2x plus 8 plus 9. So we want to begin this problem by getting all of our like terms on each side of the equal sign combined. So if I take a look, on the left side, my like terms, I have a 3x that I could combine with the 4x. So I'm going to add those two pieces together. 3 plus 4 is going to give me 7x. And then I'm just going to drop down the minus 10. And that's going to be equal to, now on the right side, I have a single variable, negative 2x. So I'm just going to drop that down. But I see I could also combine the 8 and 9, since those two numbers do not have variables. So that's going to give me 17. Then it becomes like equations we were looking at during our last lesson. So I want to get all the variables on one side. So I'm going to add the 2x to both sides, just because, remember, I like to work with positive numbers. So if I add 2x to both sides, on the left, 7 plus 2 tells me I have 9x. Bring down minus 10. And that's going to equal, the 2's cancel on the right, 17. Then add the 10 to both sides. So we have 9x equals 17 plus 10, 27. Divide by 9. So x is 3. So our answer to this equation is x equals 3. Our second equation is 100 times the quantity z minus 2/10 is equal to negative 10 times the quantity 5z plus 8/10. To solve this equation, I must first distribute on both sides of the equals. So I need to work with the 100, and then I need to work with the negative 10. So I'm going to start on the left, working with the 100, and I'm going to multiply 100 with z, and I'm going to multiply 100 with 2/10. So 100 times z, that's pretty simple. That's going to be 100z. And then 100 times negative 2/10. So the trick is, whenever you multiply by 100, you just move the decimal 2 places to the right. So I would move my decimal 2 places and find that 100 times negative 2/10 would be negative 20. Now, if you don't like that trick, or you don't think you'll be able to remember it, then you can just always off to the side multiply out 100 times 2/10, and you'll still get the same thing. Now on the right, we're going to multiply by negative 10, that with the 5z and with the 8/10. So negative 10 times 5z is negative 50z. And negative 10 times 8/10. A negative times a positive is negative. And then 10 times 8/10. The trick to this one, whenever you multiply by 10, is just to move your decimal 1 time to the right. So this would be 8. Again, if you can't remember that trick, or you don't think that you will, just off to the side multiply out 10 times 8/10, and you'll still get the same answer. Now that we've distributed, it's time to get our variables on the same side of the equals. So I'm going to add 50 to both sides of the equation. I'm choosing to add 50 because, again, I do not like to work with negative numbers. I like positive things. So 100 plus 50 is going to be 150z. I'm going to drop down the minus 20. And on the right, the 50s cancel. I just have negative 8. So from here, I want to get 150z by itself. So I'm going to add 20. When I add 20, the 20s cancel on the left. I have 150z. And on the right, negative 8 plus 20. I can also think about that reverse order. 20 minus 8. And 20 minus 8 is 12. So the last thing I have to do in this problem is I want to get the z by itself. So I'm at the point I now need to divide by 150. So the 150s cancel. I have z equals. So 150 does not go into 12 because it's just too big of a number. So what I need to do is I need to simplify this fraction if it can be. Well, I see that both of the numbers are even, 12 and 150. And I know even numbers can always be divided by 2. So that's how I'm going to start simplifying. I'm going to divide by 2, top and bottom. 12 divided by 2 is 6. And 150 divided by 2 is 75. So I have the fraction 6 over 75. Now, looking at those, I want to think, can I simplify it more? Well, I know I can't divide by 2 because 75 is not even. However, if I think about 3, I know that 3 goes into both 6 and 75. So I'm actually going to divide one more time, both of these by 3. 6 divided by 3 is 2, and 75 divided by 3 is 25. And I know that fraction's not going to simplify again. So my final answer to this equation is z equals 2 over 25. Your third and final example for today is 5/8 times the quantity 16d plus 24 equals 6 times the quantity d minus 1 plus 1. What I want to do for this problem is show you how to work with fractions. So in this problem, instead of trying to clear out, because there's quite a bit going on and it can get a little bit messy trying to clear out the fraction this time, we're just actually going to distribute the 5/8 on the left-hand side and work with the fraction. Honestly, they're not that scary, so it'll be okay. So if I start this problem, when I distribute the 5/8 to 16 and the 5/8 to 24, since I want to walk you through this, what I'm going to do is I'm actually going to rewrite this. 5/8 times 16d, and then we're going to do 5/8 times 24. It can get a little messy if we try to use the same fraction twice, so that's why I'm writing it down for you. So if we take a look, 5/8 times 16d, what we want to do is kind of the same thing when we cleared fractions. I want to ask myself, how many times does my denominator go into the numerator? Well, 8 goes into 16 2 times. So this is just going to be 5 times 2d. So it's going to become 10d. With 5/8 times 24, same thing. I want to know how many times does 8 go into 24? Well, that's 3 times. So I'm just multiplying 5 times 3. I get plus 15. And right now we've already cleared out the fraction just by multiplying it out. So again, fractions aren't scary. We just need to realize denominators mean divide, so we can start by simplifying there. Now if I continue the problem, on the other side I need to distribute the whole number 6 to the d and the negative 1. So that's going to be 6d minus 6 times 1 is 6 plus 1. And then I can go ahead and combine my like terms. Negative 6 plus 1. So that's going to stay 6d, and negative 6 plus 1 is negative 5. So just by multiplying out the fraction and then distributing and combining like terms, we are down to a basic equation. So what we're going to do is get the variable on one side. So I'm going to subtract 6d from both sides. So on the left, 10d minus 6d, that's going to become 4d. I still have plus 15. And on the right, the 60s cancel, that's negative 5. Then I'm going to subtract 15. I'm going to switch colors here so you can see where I moved to. We've got 4D equals negative 5 minus 15. Remember, two negatives when you're adding stay negative, and 5 plus 15 is 20. And then finally divide by the 4. The 4's cancel, so we have D equals negative 20 divided by 4 is negative 5. So our answer to this equation is negative 5. It is now time for you to try solving an equation yourself. I would like you to try to solve 2x minus 5 plus 3x equals 11 minus 9 plus 2x. Please pause the video and attempt this problem yourself. When you have an answer, resume the video to check it. To solve this equation, what we first want to do is combine any like terms on the left and the right. So on the left, I have a 2x and a 3x. I can add those together since both of those terms have a variable x in them. 2x plus 3x is 5x, and I still have the minus 5. Now that's going to equal, on the right side, I can combine 11 minus 9 because those are just two basic numbers. 11 minus 9 is 2 plus 2x. Now that I've combined my like terms, I can start moving my variables to one side of the equation. I'm going to subtract 2x from both the left and the right side of the equation. 5x minus 2x is 3x. And on the right, the 2x's cancel, so that's just 2. Add 5 to both sides. The 5's cancel, so we have 3x. 2 plus 5 is 7. And then divide the 3. Now, 3 does not go into 7, nor can that fraction simplify. So we'll say our answer is x equals 7/3. Your second U-try is 7/9 times the quantity 9x minus 27 equals x plus 3 minus 4. Please pause the video and try this problem yourself. When you have finished solving, you may resume the video to check your answer. The first thing I want to do to solve this problem is to distribute the 7/9 to both 9x and negative 27. So I'm going to rewrite this. 7/9 needs to be multiplied with 9x. And then 7/9 needs to be multiplied with the 27. So 9 goes into 9 one time. So 7 times 1x would be 7x. And 9 goes into 27 3 times. And 7 times 3 would make this minus 21. On the other side, if I combine my like terms, plus 3 minus 4, I'm going to have x minus 1, since 3 minus 4 is negative 1. From here, we're going to finish solving. I'm going to take my 1x and subtract it from both sides to get 6x minus 21 equals negative 1. And then I'm going to add 21 to both sides. So we're going to have here 6x equals negative 1 plus 21. Again, you can also think about it as 21 minus 1, which is 20. Divide by 6. Now 6 doesn't go into 20, but 2 goes into both of these numbers. So if I simplify this fraction, I'm going to get 10 over 3. So our answer to this equation is x equals 10/3. This concludes the second part of our lesson on Section 3 of Chapter 1, Solving Equations with Variables on Both Sides. If you have any questions, please ask Miss Brooks. Thanks for tuning in, and we'll catch you next time on your Daily Dose of Math with Miss Brooks.